about which guide you. My topic is discuss about only on force, inertia, and momentum. We will discuss about three topics in this my one video. But first of all, if you are new, also please subscribe my channel and press the bell icon so now I start my topic about force, inertia, and momentum. But first of all, if you are new, also please subscribe my channel and press the bell icon so you start my topic about force, inertia, and momentum. Hmm. Newton's law of motion. Newton's laws of motion are of fundamental importance in understanding the causes of motion of a body. Before we discuss these laws, it is appropriate to understand various terms such as force, inertia, and momentum. Force. When we open a door either by pushing or pulling it. When we open the door, pushing and pulling it. The push may move the cart or change the direction or to its motion. Change the direction on its motion. Or may stop the moving cart. A batsman is changing the direction of a moving ball by pushing it with his bat. A force may not always cause a body to move. Look at the picture. A boy is pushing as well. A boy is pushing as well and is thus trying to move it. Could be move the wall. A goalkeeper needs the force to stop a ball coming to him, and thus we understand that. A force moves to trends to move, stops or trends to stop the motion of a body. The force can also change the direction of motion of a body. What happens when you press a balloon? You can cut an apple with the knife or pushing its sharp edge into an apple. Thus, force can also change the shape or size of a body on which it acts. Inertia. Uh, Galileo observed that it is easy to move or to stop light objects that had than heavier ones. Heavier objects, Newton concluded that everybody resists the change in the state or rest of uniform motion in a straight line. He called this property of matter as inertia. He related the inertia of a body in its mass and which due to and inertia is the body is a property due to which it resists any change in the state of rest in the motion. Let us perform an experiment to understand about inertia. Does the coin take a glass and covered it with the piece of cardboard piece of coin on the cardboard. If it is no flick the card horizontally with the jack of your finger. Does the coin move with the cardboard? The coin does not move. The coin does not move with the cardboard due to inertia. Where does the coin go and as the cardboard falls away? Consider another example of inertia. Cut a strip of paper, place it on the table. Take a few coins as it once and pull out the paper strip under the coins with a jack. Do you succeed in pulling out the paper strip under the stacked coins without letting them fall? Why do the coins remain stacked? Pulling out the paper strip quickly under the stack. Momentum. On the uniform, the impact of a loaded truck on a body coming in its way, it is very large even if the truck is moving slowly. To explain such a situation, we define a new physical quantity called momentum. The momentum P of a body is given by the product of its mass m and velocity v. P is equal mv. P is equal physics equal momentum and velocity. Momentum is a vector quantity, so it says a unit is kilogram mass per second inductive 1. Newton's law of motion. Newton was the first to formulate the laws of motion known as Newton's laws of motion. First law of motion deals with bodies which are either at rest or moving with uniform speed as a straight line. According to Newton's first law of motion, a body at rest remains at rest provided no net force acts on it. This part of our law is true as we observe that objects do not move by themselves unless someone moves them. For example, a book lying on a table remains at rest as long as no net force acts on it. Similarly, a moving object does not stop moving by itself. A ball rolled on a rough ground stops earlier than that rolled on a smooth ground. It is because rough surfaces offer greater friction and greater friction and ground. It is because rough surfaces offer greater friction. If there is force to oppose the motion of a body, the moving body will never stop. Thus, Newton's first law of motion states that a body continues its state of rest or a uniform motion in a straight line provided no net force acts on it. And Newton's second law of motion. Newton's second law of motion deals with situations when a net force is acting on a body. It states that when a net force acts on a body, it produces acceleration in the body in the direction of the net force. The magnitude of this acceleration is directly proportional to the net force acting to the body and inversely proportional to its mass. If a force produces an acceleration a in the body of mass m, that we can state mathematically that Newton law force a delta 1 by m or a delta f by m, a delta f ma, putting k as the proportionality constant, we get f is equal to k m a, and 1 Newton is 1 n is a force that produces an acceleration of 1 ms negative 2 in the body of mass is 1 kg. When weight w of a body mass m is related to equation w is equal to mg, weight is a force and thus it is a vector quantity. Its SI unit is Newton, and it's well said that Newton's third law of motion deals with the reaction of a body. Deals with the reaction of a body. Newton's reaction of a body when a force acts on it, and to every action there is always an equal to opposite reaction. I know very well. According to this law, action is always accompanied by the reaction force, and the two forces must always be equal and opposite. Note that action and reaction forces act on different bodies. And consider the book lying on the table. The weight of the book is acting on a table in the downward direction. This is the action. The reaction of the table acts on the book in the upward direction. So, my dear friends, how is my topic? I hope you like. So, we meet our next new topic. Please view my channel. Please subscribe my channel. Please like and subscribe my channel. So, now I am going to my new topic.